welcome back. We are comparing line graphs. Now, looking at this chart, I have grade and I have homework, and we're looking at how they correlate to one another. So in grade 1, we're expecting a grade 1 student to have about 10 minutes, grade 2, 20, all the way up. So what is the trend that you're seeing here? Right? The pattern is for every grade, you're doing about that amount of minutes in homework, so multiplied by 10. So grade 4, 40 minutes, grade 5, 50 minutes, and so on. So following that trend, what would you expect a grade 7 student, the average amount of homework could be? Right, like 70 minutes, an hour and 10 minutes. And if that trend were to continue all the grade 12, what would the average grade 12 student be doing? Yeah, so you would expect 12 to be 120 minutes, which is 2 hours. Now, to me, does this make sense? I ask you, does it make sense in your head? Do you want to be doing 2 hours of homework when you're in grade 12? To me, I think this is unreasonable. So we need to think about the dangers of making predictions for values that are too far ahead of the data that we are provided. Now, if I was going to draw and plot this using a broken line graph, this is what it would look like. So I have my time here, I have my grades here on this side, and then on the grade, I have the dots because there is no half grades. I'm not in grade 4.5, right? So it's not going to be a straight, steady line. Now, looking at the average precipitation in millimeters by month, I'm looking at Whitehorse and I'm looking at Victoria. Okay, so just as we can create double bar graphs to compare two sets of data, we can create double line graphs as well. So how must two bar graphs be similar so that we can transfer that data to a double bar graph? They need to have the same units with the corresponding axis, with the y and the x. So what changes might be necessary? Well, you'd have to change the scale, right? So good choices for this scale would be 0, 5, 10. And then for Whitehorse, it could be 0, 15, 30, right? All the way up to 165. So that we include this here, right? So Victoria goes farther than Whitehorse. So we need to make sure that we have a scale that's going to include that. All right, so we create our double bar graph. So I'd like you to do our line graph right now. I'd like you to pause the video and just draw that out. Now, when we analyze the graph, what are the wettest and driest months in both places? Okay, so the wettest places in Victoria would be up here, and the wettest is in Whitehorse is here. Now, when is the weather drier in one place than the other? So if you're thinking about that, it's drier here in the summer months in Victoria, and it's drier here in the winter kind of fall, spring areas in Whitehorse. Now that might be the case because, you know, when it's snowing in Whitehorse, it might be kind of dry, which would account for the precipitation being lower, and then everything starts to melt in the summer, so it gets kind of wet. And then we would have rain and everything else. So being lower in the winter than in the summer. And then in Victoria is warmer and the precipitation comes mostly from rain. And I lived in Victoria and there is a lot of rain. So that's where the difference with precipitation would be. All right, that's all I have for you today. So make sure you get your worksheet done and come to the help session.